Tom is no stranger to Scotland. He has worked with Eversholt before that and had involvement with the Class 318s. So he's well aware of the Scottish product. He'll know some of the teams. So great to have you back in Scotland again. And before that, it was with Wabtec. So he's, I've got to admit, I spent a lot of time at Springburn Depot. I think spending time at an overhaul site or refurbishment site, I think brilliant, really good engineers. So for sort of cracking on with things, I'm going to pass over the phone to Tom. Really look forward to your presentation. We'll get Q&A at the end, and thank you again, Tom. Over to you.
Not a problem. Thanks, Ian. So yeah, Tom Lendhill, currently the engineering manager for Hitachi for the Azuma fleet on East Coast. And hopefully, sort of as Ian alluded to, I was thrown this rather than 2 weeks ago. It was 2 days ago, but I've managed to cobble some slides together for you, and hopefully we can breeze through the slides and then sort of open it up to have sort of an open discussion that we perhaps couldn't have had if it's the normal event. But hopefully this will make it a little bit more personal, and we can just sort of, any problems, any queries that you've got, we can just open the floor and sort of have an open debate about the problems that we've seen. So I'll just share my screen with you. And if you've got any pressing questions, just sort of try and jump off mute if you want to, and sort of open the debate where you need to. So I think the flyer and the sort of the mandate for this presentation was to sort of give you an overview of the troubles and the problems that you face while introducing a new fleet. So hopefully I can sort of look at what that's, what that looks like from delivery, and then more day to day. As I said, I've been here for 8 to 9 months, so I can definitely tell you about the woes of the day to day, the maintenance, and then moving on to heavy maintenance, and how we deal with the operational railway rather than the project world. But I will focus on a couple of project specific problems, but then obviously my main area of focus is on the day-to-day stuff. So bearing that in mind, let's move across a brief overview of what we will discuss today. I wasn't quite sure of how many people, I know these IMechE discussions, a lot of people already know the train more than I do, which is interesting. So I'll give you a brief overview of the sort of technical specification of the fleet itself, just to and sort of the infrastructure and the sort of the wide range of the project, where we operate, that sort of thing. Move you through some of the technical issues from delivery, try and sort of allude to some of the new technologies, maybe differences that we've got now with a new train, have a look at some of the current performances, and then have a look at where the future challenges lie, because obviously nothing's ever easy in railway. So we'll keep moving. This is sort of a brief overview of Hitachi itself. So obviously the Hitachi, you'll all be aware, sort of have a footprint across the world in a number of different areas of railway, which is rolling stock manufacturer, signalling systems, and other sort of digital experiences that they do have. So that I think it's sort of an end-to-end provider of the product, and then the maintenance for that. So and the contract that we have on the East Coast is sort of through life, isn't it, that everyone's aware of. So what do we do? Where do we operate? And from Hitachi, it's not just specific to the East Coast main line. We also have units in the west of the country. We have TPE, so running from Liverpool all the way up to Scotland as well. We have 385, slightly different product, but very, very similar. But a metro fleet that we've sort of got up there, which is going well. But the sort of where we sit across the country, we do have a large fleet out there, and we are getting bigger with East Midlands and West Coast partnership. I think we've got a couple of people from those talks that are sort of going to get new trains, which is all good fun. We've also got Hull trains and East Coast open access, which is in the pipeline as well. So Hull currently got 5 units on the East Coast as an open access operator. And then not to forget our 395 Javelin, which is HS1 in the southeast. So in terms of the sort of the East Coast, I want to just touch on a few sort of main things that all you guys from Scotland will be aware of. But obviously, getting north of Edinburgh, the issue of overhead wire seems to come into play, and the wires run out, and which sort of is very key for Scotland in terms of what the product was and how the design was shaped to be probably, we're here in West, that it would be one of the first real bimode fleets that are across the, used in anger in the UK. So we'll touch on what sort of problems that brings. And I noticed a few signal engineers that were on the call as well. So they'll be sort of keeping their ears out for the power changeover that we'll sort of go into a little bit more. So yeah, the IP project sort of overview, the DFT sort of led program, which was to replace some of the iconic fleets that we've got on the East Coast mainline, HSTs and 91s and Mark IVs. So I mean, they're almost from LNER perspective, the HSTs are no more, but 91s are still sort of in operation. So like I said, it was a large government contract over 27.5 years. So it is really cradle to grave from an asset life point of view. And the technical specification, we had electric and bimode trains to accommodate for the passengers that we're using from Scotland, and really speed up the services from Inverness, Aberdeen, all the way down to London, King's Cross, and sort of improve journey times across that. So I think it was all about improving the products, getting the bimode products out there to improve journey times, but also try and enhance the passenger experience. Whereas we all know that's quite subjective. So feel free to jump in with people who've been on them, feedback, stuff like that. It's always good to compare them against the sort of the older stock that was there. I know we've got a lot of people who love those old things, and it's quite hard to let them go. But unfortunately, they do have their time, and they will slowly be phased out. And Azuma will be sort of the fleet on the East Coast. So this is just some numbers across, how big it will be. The platform is obviously going to be the UK's largest high-speed train fleet in terms of sheer numbers. So I get my day-to-day is looking after the 65 units for East Coast, or LNER, should I say, on the East Coast for LNER. So that's sort of my day-to-day. So I'll move in. A couple of sort of facts and figures across for you. Max speed 140, but the operating speed 125. So ETCS level 2. We've got a GU from MTU Rolls-Royce, which powers the three-phase AC drive. I'll give you a quick overview as well if we sort of go down a little bit in terms of the layout. Maybe it's better using this slide just to sort of talk you through some of the key components and manufacturers that we do use. So we've got KB air system and brake system. We've got Hitachi traction motors, or a subsidiary of. Interior is, and the passenger displays is Televic, Pantograph, Brecknell Willis, as you'd expect. And for those that have been on the units, I think they do look pretty smart with passenger Wi-Fi, all the modern things you should expect of a modern EMU fleet. And this is sort of just a bit of an overview of the 5s and the 9s and where sort of things exist. So you've got on a 5 car, you've got 3 powered vehicles, and on a 9 you've got 5 powered vehicles. So you sort of, I think some of our Scottish friends will remember times gone by with HSTs and buckets of sand and trying to get up large inclines in certain parts of the routes. I'm sure some of the HST people will be more than familiar with that. Hopefully that's no more. With sort of a modern, with more sort of powered wheel sets, we can deal with the infrastructure a little bit better. In a modern WSP system, we can avoid the issues and improve the sort of delivery to passengers, which is all good fun. For the electric only units, we do have a single GU, and so that's the generator unit from Rolls-Royce, which powers the hotel loads and can get you out of a tight spot if there are no OLE available, you can sort of scoot at very low speed on the donkey engine, that we call it, to get out of dodge, which is pretty handy if there's any problems with the OLE, and can sort of it is there to be used as a sort of a rescue scenario to reduce the impact on passengers. So let's get across into sort of staying on, with the problems of introducing the new fleet. And the first picture I have to apologise for, because trying to get automatic power changeover into a small picture for a slide on Zoom seems to be one of the hardest things that I've done in my career, and I've certainly done a bit of a bodge job of it. But the top right hand side, sort of talking about what's new and bespoke to introducing this fleet of trains. Well, with the new bi-mode sets and the sort of DFT-led specification, we needed to work with Network Rail and our operator to deliver automatic power changeover. So that requires a lot of sort of a novel design, new approach for the UK that you would imagine. I think we were first on the West. They used BRATP and been using it manually. So here we were taking the lead on the automatic function. Essentially what that does is lowers your pantograph from electric to diesel automatically if you're going to go into areas where OLE is not available, and then vice versa when you're coming out of that and you want to use the overhead line, you can do that automatically. Obviously we've seen that on East Anglia. We know it's a problem if you don't get it right. You end up looking kind of silly with your pantograph smashing into rail bridges and what have you, which is not easy. It's also collaboration, with the train design to Network Rail infrastructure. We're constantly learning with this new system, and obviously any safety implications are quite high, as I've mentioned. So trying to align all of those planets is sometimes quite difficult. So we can chat about that at the end when I open up for questions. Another significant modification that's been put in from design was the change of the intercar jumpers that you can see on the bottom left of the screen. I think it was in response to an incident on the West Coast Partnership on a Pendolino, where unfortunately a passenger or a surfer had jumped onto the top of the roof using the intercar jumpers as effectively a ladder. A sort of a massive design sort of in terms of the project to change the intercar jumpers that we have to improve the solution on the high voltage and low voltage side. So all of the communications of the train run through there, and to change the length of them seems like an easy job, doesn't it? But obviously that wasn't quite designed to be remodeled and repurposed. So you can imagine the problems that arises in getting that right, and the testing for that. So we're sort of midway through the modifications of that, and it's going pretty well. But yeah, to be dropped onto you for the when you're trying to operate the fleet in the earlier days is obviously something you would like to avoid from a design perspective, but for whatever reason, we sort of caught that in the middle. A few more technical issues. Again, a terrible photo I took on depot today of a reactor mod, which sounds really fancy, but essentially this was quite a big piece of work, which a new train running on older infrastructure causes its problems, and some of the signal engineers will know a lot more about that than I do. But it was seen in the early days when we were testing these units on the East Coast in around 2015, 16. The EMC issues were being presented with trackside solid state interlocking systems. So to sort of remove this vulnerability of the and safety aspects involved with altering signals, the decision was made between all parties that it would be easier and more effective to amend the train rather than amend the infrastructure. And what sort of came of it was that all the traction motors now have this reactor mod, which reduces the EMC harmonics, so that you can use the trains on the infrastructure that we have. And obviously that will grow over time. I thought I'd put in a picture of software updates, which it seems that now we're moving to a more sort of software-based train. It just seems that constantly we are refining and tinkering with the software that we have in all locations, whether that's the main TMS system itself, or whether that's individual specific subsystems such as your brake systems or traction software that you would like to do. It seems that that you will have a job for life if you were going to do this. Look after the software document that we have at Hitachi. It seems that we are constantly trying to refine that, and that presents its own issues when you look to implement them on the units, because obviously you've got the worry of compatibility within systems and subsystems, and you've also got, you don't want to do that reverse, so you need to be pretty tight with your documentation and how you implement change, because you don't want to revert back to type, which may bring in safety or reliability issues. So that's one thing that, you know, I think is slightly different from a new fleet. You do have to continually do these, continually improve, rather than, you know, something that stays pretty much tried and tested for the rest of its life, which I think was probably the par for the course with the previous fleets, or my experience on previous units or relay controlled logic trains. I wanted to breeze over some other factors as well. So obviously infrastructure. I sit today in Bounds Green, which many of you may have worked here. A lot of you will be familiar with Craig and Tinney, sort of older depots, which were built many moons ago, but have obviously been repurposed for many different fleets. You take that with a brand spanking new depot pretty much in Doncaster, it's certainly an interesting one for your production managers, project managers to deliver light maintenance consistently. So you obviously need to get everything that you need to in place, simple things to make things lean. Obviously it's not going to be the same throughout 3 different locations, and each one presents its own problems, and each depot is like a bit of a basket case, isn't it? For those who know, even in a cultural sense, it can be majorly different between depots, and that's something you need to overcome. Also put on people there just to sort of show the difference. I've got a good example of people that we have, and maybe be the top engineer on 91s, and you ask them to give them a new toy, and it's like they're back to being an apprentice again. It's obviously they have bags and bags of experience, but this is different. You need to know spreadsheets, you need to know software, you need to know online servers, you need to know all of this information to get the information that you want. A lot of it is buried in between software specifications. It's not as easy as sticking back to your old schematics, because a lot of those send a wire into a black box, and then you need to work out what that black box is telling you. And then you've got some of the softer side where maybe you've got Bounds Green where you've had a 91 and an 8300 in the same place, but you will have 2 different approaches, 2 different trains. It's also that thing that you need to sort of take into consideration. And it is really hard work to change that and change the mentality and mindset of the staff, lead techs and your production managers, and this is different. So I'll flick on some things of where we are at the minute, where we think we're going, and then sort of I'll flick on to some of the problems that we have. So that was more project led, but this is more into the day to day. I wanted to show this graph. We had some feedback from LNER about the cancellations, on time performance improvements that have been apparent since we've sort of introduced the Azuma fleet. And I think that I'll hopefully sort of tie this together when we come on to the sort of modern day challenges, but hopefully it sort of sets the benchmark that we were chatting before the meeting with Ian, saying that the product itself is pretty good. But as ever in these early stages of the fleet's life, it's positive sign, but it's all about understanding the problems, working through the issues that we have day to day to build on this start that we have. So I think we have had an improvement in reliability from the HST sets of 91. So that's a really good promising start. And the bottom left is sort of the reliability growth predictions that we sort of throw together. Cancellations down, on-time performance majorly up, but COVID might have affected that for the better for us, and the Golden Spanner winner last year for the electric fleet. So we're in a good position, but there is certainly bags of issues that we see that we want to overcome, and the challenges at the minute for maintaining this fleet. So hopefully I can sort of build on that. And a lot of it, so we were chatting before, is about this train is new, it is more up to date. It has the sort of functionality that you would expect from a data side of things. So you can get information from this train that you never, as engineers gone by, would have sort of loved and snapped your hand off to have all this information coming to them at once. And I think there's 40,000 signals per train that we get at any one time, which sounds really good and sounds like it should be really easy. But let me and it's when you break it down, that gives me 40,000 problems to understand and to risk assess and to try and sort, which is obviously a problem that we never had in times gone by. So you can obviously be overloaded with information, overloaded with data, feed that back into people who might not know how to interpret it, and you've got big problems there when that comes just in terms of defect analysis and understanding it from an asset monitoring point of view. How you sort of use that to your advantage on the right hand side of your screen here for reliability, availability, optimizing production and predicting defects is very difficult. But hopefully I can sort of show you some of the benefits of having that data and some of the problems that we're hoping to overcome at the moment. So I'll sort of flick it onto the next screen as a bit of a discussion slide that we can obviously come back to, because I think this part of the presentation is obviously best as an open forum, so we'll come on to that. But things we can do now that we could never do before. So I think we've done it in various forms. Don't get me wrong, with emails, alerts and notifications. That's not really too groundbreaking. I'm not going to get too excited about that. But remote fleet checks and remote maintenance, that is remote fleet checks for a start. If I have a problem with the software, I can look at any one fleet within a relatively short period of time to prevent people having to go to units, do things. I can click on the units. We have a monitoring tool that you can see on the top right hand of the screen, and I can interrogate a number of real-time signals coming from the train. So that gives me and sort of maintenance controllers the opportunity to make quick decisions and the correct safe decisions should they need it, which is great. It also sort of prevents safety incidents, or we can act on certain trains which might not be behaving, and we can do reactive maintenance when we need to, which has always been a problem. Other things that we can do is predict maintenance, hopefully, which is very difficult, but we are starting and trying to do that, which is good. We can also understand system duty cycles, which again sounds pretty easy, but I think it's always been difficult to do that consistently. For example, we can work out exactly how well we can use the remote diagnostics to understand which pantograph's been used more, how many coupling operations have been happening between the different 5-car sets, and which sides are getting worse and used more often than not. So we've got loads of incidents where we've done that, and we've seen it, and it's really interesting. The example that I've given you on screen is sanding applications, and it's quite funny because I used this and showed my boss, and actually his house is on the picture of the map in the bottom left, which was pretty funny when I was trying to tell him that basically what I was looking at now with the data is understanding not only just across the Pareto of each unit, but the wagon wheel looks like that's time in the day that sanding occurs. And then I can also look at the start speed and the CPBC position. So for me, it's a bit more of it moves towards a science project to say, okay, am I sanding more? You'll have your WSP that then results in sanding and locked axle if it gets to the wrong end of it. So when it is at sanding or locked axle, when is that? When am I, can I test the adhesion limits of the railhead? Do I know these places where this is occurring? And sometimes it might be driver, it might be system, and it might be infrastructure problems. But hopefully using data in this way, as you can see, near my boss's house in Doncaster. There seems to be a lovely place where we like to deploy sand for whatever reason. And this sort of thing that you can't see now on my PowerPoint, but this is all interactive using Power BI. So I could click on any unit and I could go to any point in the map to show you which units are suffering, which is a really handy tool when you get it down to this level of granularity. But I will say it's very difficult to do so. And there is if I was to show you that map with it not filtered, you'd think that there was lots of issues going on with the train, but then you'd realise when you use the GPS that it all happened on depot, so that you can sort of you need to be mindful of that so you don't give yourself a heart attack when you're especially when you're looking at sort of safety related defects or TMS events that you don't want. So that's certainly how we're trying to tackle these problems and overcome certain problems with the fleet. But again, you feed it back into people expect to be told problems, I guess, in this day and age. And you have a computer that tells you there is a fault alarm, but understanding that and having an inherent nature of what the software is detecting is also something that is difficult and usually buried within the sub-suppliers sort of IPR. So it's something that you do need to really understand, and it's very interesting when you get into it. So before we sort of end, hopefully that we can use a lot of the time to discuss, and that'll just sort of give you a brief overview of where we are and what the problems we've faced so far. But yeah, really keen to open it up really to have a genuine discussion rather than sort of me tell you that it's difficult to introduce trains, because I think everybody on the call is well versed and knows that, but I'd like to sort of open that up if that's possible, Ian.
Tom, we have a number of questions on the chat panel, and we'll go through them. We'll come back to seat and comfort at the end, because our first question is from Peter Woodbridge. He's actually sent two, but maybe first one on cables.
Cables, yeah.
Yeah, Peter, do you want to set your question?
Well, I could do if you like. Really, I just as a passenger, I just see an awful lot of cables between the vehicles there, and I don't generally see anything like that number of cables between vehicles. Now, I reckon that some of them are probably duplicated, but there still seems to be a lot. So can you tell a signal engineer what they're all for?
This for you through train control. So there's literally everything goes through those cables. So if anything that you want, any wire that's popping through there, there's usually, there's everything you can think of passes through those intercar jumpers. So that could be from your traction side, also signals that come through to your brakes and hardwired system for that. So there really is no end to what is through there, which was sort of when you go to change it and when you go to amend it, it's not something that you want to disturb. It's certainly something that people try and avoid. And usually I've come at this problem from overhaul of fleets and and older stocks, so 91s that I've got experience of, that the post-test procedure of that needs to be pretty tight to find out any issue that you've got in there. So yeah, sorry for the vague answer, but it really is anything that pops through there. So
it just sounds to me is like everything's on its own individual wire, and it's not sort of multiplexed in any way through some form of transmission system.
Right. Okay. Well, you do have that, and you do have the network of the system, but it's all, so you'll have like an onboard server there's vehicle interface units that take signals. So you'll take a plethora of signals from each individual subsystem, which will be either just hardwired signals, or you'll have all sorts of digital inputs from the subsystems, and then that goes through the onboard server, through the sort of your modem through to your router, through to the TMS and the onboard server on car 2, and then that goes into the computer of the train. So you've got that, but then you also replicate all of that in the hardwire, because you've got that as your backup. So you've got a mixture of both, but to operate the train. But yeah, you've got mostly the hardwire that goes through that. Yeah, the router sort of Ethernet wired through, if you like, for those that are used to at home. So you've got that as your primary system, but you fall back to your hardwire.
Right.
So yeah, we have had it in the past where you can lose, if you lose connection on that system, it reverts to the hard wire, so that there's actually a second router system and then a third hard wire if you need it, to give you redundancy actually on this set.
Our next question is from Andy Roberts on assurance. Andy, do you want to set your question, please? Andy's gone quiet, or he's not, or he's got himself on mute.
There you go. Even I'm prone to going on not muting myself. Yeah, my question, yeah, as a manufacturer, do you feel that the relevant approval processes, and there are a multitude of them, are fit for purpose? Because the recurring theme of new fleets is they meet the mandatory requirements, but perhaps the end user, as the passengers or operator requirements, have reduced priority early on in the project, but unfortunately they tend to bear truth and difficulty and create the difficult industry headlines once in service. Seats are top, but there are a multitude, be it PIS system functionality, performance, traction performance. What's your thoughts on that?
I think across any subsystem, I think we were laughing before. I think one of the sort of well-known issues across any fleet, I think Azuma's was one. Siemens tended to be another one, where people focused on the hardness of the seat, which we were joking about prior to this. But the sort of prior consultation in that aspect alone for this train was quite unprecedented for something as much as a seat. But people still don't like it. Take that into something that's a bit more serious, or even more passenger related. I think it is very difficult, and I think in these situations, we always need to need to open up the dialogue between the standards and the manufacturers and the standard setters, and the DFT. We need to be very open with it to set the mandate for what the specification needs to be, if you like, because like you say, it's very difficult and sometimes it can be subjective. So take into that as well with a new modern train, sort of things become obsolescent after a very relatively short period of time. So would we think about, as a designer, surely it would be best to think about something that can easily be updated, or can easily be replaced in the future. That needs to be taken into consideration, doesn't it? I mean, passenger, who knows what a passenger, take COVID for example, and what LNER have offered that I know of is at seat service. Well, who would have thought that a train would have had an at seat service prior to COVID times? Would a contract that we've signed to deliver a PIS or anything of that nature be able to cope with that change and the rate of change that we need? Is a standard going to change that quickly? I think if we all talk together here, we know that that's not the case, is it? So I think as service providers to passengers, to operators and to the DFT, I think we need to, as a collective, be open to change and make sure that that perhaps contracts are sort of are flexible enough to allow them to do that, so that it moves with the times, if you like. You know what I mean, Andy? You don't want to be stuck in that train that was relevant 3 years ago, and you've just delivered it because it's taken you that long.
Thank you, Andy. Thank you, Tom. Probably just a supplementary on that. You touched on seats, and Peter mentioned seats as well. Do you maybe give an explanation of what you did with your seat? Because seats is one of the things you can say, yeah, I've got a compliance to the standards, and
Right.
no bugger was sitting there to a certain extent. Do you want to say the good and bad on seats?
Well, it's funny because I used to spend a lot of my early career hungover on 91 seats, so I do know the joys of a big comfy seat on that, and spending many times sleeping on the way back down to London after visiting friends in Leeds. But in terms of the seat on the Azuma, there was a massive consultation, and everybody was sort of calibrating the seat, if you like, from their own experience, and that was chosen as the best for then it to be sort of quite openly mocked in sort of rail articles, and I think Siemens suffered something similar with the 700, where you would be expected to, albeit a compliant seat, but you might not want to be on it for any great length of time. I don't think that's quite the case from my experience on the Azumas, but then again, that's quite subjective. I don't have any lower back problems, so maybe when I'm a bit older, I might be changing my opinion on it.
But Tom, one thing you did mention that was quite interesting, I wasn't aware of. There was a choice of seats. There was a case of nice possibly it's a compliant seat. Take it or lump it. The contract says a compliant seat. There was a choice there. Okay. Any other comments on the seats? On you go, Bill.
Where are we? Well, thank you, Ian. What would I say? I suppose a good question to ask is what's the competition doing? And I'm just wondering if anything remotely like the Azuma seat is available in a BMW or a Mercedes at the moment. And I've not seen one. I suppose if I take the long view, the Midland Railway in the back end of the 19th century shocked its rivals by introducing padded seats for third-class passengers. But the thing is, they'd worked out that offering comfy seats attracted more business. And it wasn't long before all of their competitors were having to do the same. And I think we are in a transition from running a railway where our problem is increasing demand and how on earth are we going to provide the seats, to a period when the alternative is not to travel at all, commuting won't be happening like it used to, and we actually have to entice people to use our product. So my firm prediction is we will prize, as a matter of sound business practice, more comfortable seats than we have fitted to trains in recent years. And it's an area that as engineers, I think we have to think ourselves into that new business paradigm. So personally, I don't like the Azuma seats, but that's just a personal observation. Practically, I think they limit the revenue earning potential of an otherwise brilliant new train. And so from a professional railwayman's perspective, I also think they're a bad idea.
Moving on to Malcolm de Bell, you've got a question on electric to diesel changeover.
Yes. Thank you, Tom, for a very open and honest presentation. The thing about electric to diesel changeover, I'd understood there were all manner of things that needed to happen properly for electric diesel changeover. First, preheating the diesel engine. Secondly, starting it. Thirdly, taking power. Fourthly, lowering the pan. And I thought that was an automatic system based on GPS location built into the train. Then you also had a backup with ETCS type balises on the track that would would supplement that in case the GPS wasn't working. And the final check was if none of this has happened and the driver passes a sign, he's supposed to press the button. Is that how it works?
Yeah, it sounds like you need a job in our signalling department with that brief overview. It's certainly better than mine. You look at I know the picture was terrible, so my apologies, but you can see that, I think I put it on here, but it might be the electric version that we've got. This is the electric to diesel because you've got the zero balise. Can you see on the top right-hand corner? Yeah. You have to stretch your eyes, but essentially, yes, you get preheat, which is GPS. Then your engine starts, which we want to happen 100% of the time, which can be interrupted for whatever reason. But then you bring the pan down automatically. If it hasn't done, your zero balise should protect you, and then you have the at any point the driver can press pan down. Obviously,
am I right that it would still work if none of the balises were present because the train knows where it is?
You would need it would need to read a balise.
Okay.
Yeah, and if you don't, sometimes you need a head code in there to understand where the balises are, because it looks into the database to say I've travelled X amount of miles from my last station, I am going to be at a Belize. Am I? Yes. Sees the Belize, acts on that. If it doesn't have a head code, then every time it sees a Belize, as a matter of safety, it would do a traction changeover to make you safe, because the train doesn't know where it is at that point. If the head code wasn't entered for any reason, but it should be entered as the driver gets on the train. But
as we read in the Neville Hill report from the RAIB.
Right. Okay. Yeah.
Can I ask my other one, Ian?
Yeah, on you go, Malcolm. Fire away.
Yeah. Are you able to tell us anything about the proposed trial of a battery instead of the diesel gensets?
Right. Okay. This isn't well. This is sort of. I think it's going to be led on west from an internal.
Oh, it's not on the East Coast.
No, I think the original. So I was involved in its early days of sort of idea creation. It's not. I don't think that's anything I can't say from my previous role, and I think it's well known now in most places that they're looking to partner with Short to develop that. So I don't think that's. But that's on the west coast. Yeah. So
okay.
I think Hitachi has done that in previous sort of applications. They've done it in different parts of the world, and they have had a successful battery train launch. I'm not too sort of up there to speed with the details, but I know it has been done. I think they would draw on that fact to bring it across the diesel. But it's probably a good point, because to get into the politics of it, and why do we have a bi-mode train? I think someone mentioned it earlier, obviously. And that's the way that the industry has been led for a number of years, which might confuse some people. And obviously, there's an open debate between engineers. Is that the right thing to do from an environmental perspective? It's a good point, and we probably need to address it. And like I said, with it, what we were talking about, is it right for passengers? I think we also we can do big changes like that should the sort of industry dictate it. And why would your generator unit be any different? It's just another part of the train that we can improve. So if we need to get rid of it, and it's worth it and it's viable, and that's what we want to do, then we should obviously be looking at doing that. With the generator unit as is, it feeds into your traction motors, and that's great, because you can sort of make another generator, if you like, and take that one out of there that's not powered by diesel. So obviously we are looking at that, and I think a number of people are looking at that in the industry, which is great to see. But yeah, like we said, this has sort of been led and the power changeover will still work. It'll just be a different power generator, won't it?
Yeah.
Which will be good.
Yeah. Thanks very much.
Thank you, Malcolm. Thank you, Tom. You're my next question, Richard.
I've actually got the spreadsheet for all the stepping distance for all the East Coast platforms.
Okay.
So I know the work that everybody went through to try and optimise the stepping distance for those platforms. So, but yes, the question I've got, Tom, is with all the data and the information you've got, do you see Hitachi as moving towards replacing components and undertaking maintenance on condition rather than on periodicity? Because I do see that as having potential financial benefits for Hitachi in not having to replace items that still have some life left in them.
Yeah, I think so. My background, when I was at Roscoe previously, spent a lot of my time trying to get this type of thing onto older trains. Studied at Manchester University in condition monitoring, and it's really interesting, isn't it, when you actually get. So you have that sort of theoretical based approach to it, and it's certainly sort of starting from there. That is my ultimate aim as an engineer, to do that, and it's obviously all within the books that you can read, the guidance, and it all sounds easy. When you try and do that, it's bloody awful. And trying to change a lot of the mentality that we have now to believe and trust in information and data is great, isn't it? So I think you're always going to have the problem. So that is going to be the goal. It certainly is going to be that. And I think that's from an engineering led. Obviously, don't get me wrong, the car will be happy and everybody involved should be trying to reduce the cost and not throw away items unnecessarily or do things that you don't have to do in this day and age. We need to be conscious about conserving
And you actually cause failures by undertaking the maintenance because you start to disturb things.
Exactly, and it's
and I would expect there's quite a bit of good practice from Japan that you could build on, I would thought.
Exactly, yeah. So I mean, we're doing a number of good things and replacing the older style VMI based sort of information. The one problem you're going to have is data. Can you continually gather data at the correct periodicity? So do you have any data loss? That's one of the big issues that you face now moving into that area, because not many people understand, what happens when you lose that data. What happens if the unit doesn't quite give you the information you based your whole maintenance regime on? You're then blind. You can't make that decision. So you also need to think about where you fall back to. Because this is the interesting thing that we're trying to explore with at the moment. There's easy wins, obviously, but the bigger, just targeted maintenance and predicting, sort of doing the maintenance as and when you need to, is obviously very difficult to predict sometimes. And that's one of the major problems that you see. But you need to get out of that mindset. The units that have come in, the maintenance philosophy at the time was VMI based. So moving that towards data based is certainly a challenge that I'm up for the challenge, and it's going to be. I
think your big problem is going to be planning it, because you're not going to know what maintenance is scheduled, and it's how you respond to that and how you can cope with that. But as you say, you've got all the data. You just need to work out the envelope which is safe to continue in. So
exactly, and it's a different. People, then you get into sort of the other side of it. So are you going to have technicians sat there doing nothing? Are they going to be a pit team waiting to come in to whatever fault throws its way? So, there's certainly stages to it. There's great practice that we can do. I think, with the team that we've got and really trying to excel in this area, I'm interested for the next, 5 to 10 years of where this takes us. Like I said, I could talk about it for a number of hours because there's so many challenges that you face with it. And then I've got to convince my operator that it's a good idea under their safety case. So there's a lot of trust there, isn't there, as well, and a number of stakeholders to manage to make this work. In terms of delivering pretty graphs and telling the sort of things that happen is quite an easy thing to do. I think bedding that into your day-to-day processes is something entirely different, which is certainly an area that the rail industry needs to work on, and that's sort of hopefully where my team, I certainly try and challenge them to do that in all areas. So hopefully we can do that for the better, and the benefits for reliability, they are there, and we can and availability are great. So we need to sort of realise them.
Thank you for that, Tom. Tom, just a supplement to that, I want to question. I said, do you actually employ, I'd say, online technicians whose sole job is just to search and look out for things that are about to go wrong?
Yeah, so we've got a data analysis team. So I think there's 5 people in that team currently, and they sort of work take them as like consultants. They're internal, but they're sort of consultants to me, if you like. But the great thing about that is quite funny. So with COVID, we've got a guy who's been looking at all the door signals, but he's never seen a door. So he can tell you when there's a fault with a door, but he's never seen one. He wouldn't know what it would look like if it hit him in the face. And now COVID's coming out. We've got a door rig that we've got for testing equipment, and I promised him that he's been telling me obviously when signals change, the open and close speeds of doors, and then I'm like, I'll treat you and I'll show you what a door looks like, and I'll show you the door push button that he knows is a signal on his spreadsheet, but he'll never have seen it in real life, which is, I think, is quite funny. But yeah, we do have those people that take, obviously we have sort of arrangements in place to take the data, to cleanse it, to put it in a place where we can access it. That's the first thing, the storage of it, because you've got 2 separate repositories of the data, which is live signals, and then you've got all of the other stuff that we get when the train hits a Wi-Fi spot, which is normally at major TMCs. The more we expand that, the better the less data loss we have, the more we can trust in it, the more we can keep going with it, and the more we can use it.
No, thank you for that, Tom. We've got a question from David Sherries on on the key difference between the 385 and the Azuma. David, do you want to expand on your question?
Yes, actually, you basically introduced my question for me, Ian. Just listening to what you're saying there, Tom, and from what I can recall of the presentation that Tim Alton gave us last October, which, by the way, is available on our webinar hub for anybody who's particularly interested. It strikes me that the Azuma maintenance philosophy and systems are pretty much identical to the 385s. Would that be a fair comment?
Yeah, it is. Yeah, very similar. Yeah. It's almost, very variations of the theme, but they're pretty much platform based. You can, when we have, if I talk to the engineering manager up there, you have similar issues, you can share that knowledge across.
Is there much remote condition monitoring done from remote sensors in stabling plants and such, like monitoring, I don't know, brake pad wear and pan carbon wear, that sort of thing?
Yeah, so we have a system, MRX, I think it's a Siemens system, isn't it, for those Siemens guys that are on the call? I think MRX is a Siemens-owned company, which we are currently trying to get online. We've been using it, but we're sort of going through validation at the moment just to get the confidence in the wear rates that we're seeing. So we're doing a lot of manual checks alongside the data, but you need to do that to sort of believe in that. I think Hitachi, sort of wider news, we bought Perpetuum, which is planned, which for those who don't know is vibration monitoring equipment. I think they're primarily for wheel health and axle monitoring health. So they monitor the vibrational signals, which I've been heavily involved with in a past life. Now Hitachi own them. We'll be fitting them across the TPE fleet as a trial, and those guys are pretty good. So you get that, it's basically an accelerometer, a self-powered accelerometer on the train, which is great technology that you can use to predict or prevent hot axle boxes and bearing failures that you have, which is great information. And then, yeah, like I say, each system level now is getting to the point where they have some type of diagnostics all in different forums and different sort of levels of sort of different sort of philosophies, and some are harder than others. That's what I'm trying to say, to get the functionality from that you want, but all of them have a bit more than you used to, if you like.
Yeah. I've got a question from Bill Reeve regarding signalling systems. Bill, do you want to set your question? Bill's going quiet. Bill's
He's not muted, is he?
He's off camera, so he might be. The question is, how is OptiWare? Bill?
There we are. Sorry. Well, I was intrigued because the Azumas are one of the first fleets to have been built with inbuilt ETCS level 2, and you've got the big mainline trial at the south end of the route, and I just wondered what the reality of the trials is in terms of interface and ease of interface with the trains. You've designed them to work. Has it worked as designed? I'm just interested in your reflections on that.
Well, I think from ETCS, we will. I think we're not running it in anger at the moment, are we? We're sort of waiting to, it's rolled out across the country, and I think we've now agreed that we'll be taking sort of the lead in a number of those areas. So we will probably, I think it will be coming a little bit quicker than we expected. I think you joked that ETCS was never going to happen in these forums. It seems like it's always been pushed back, but that seems to be coming to the fore now. So for me personally, it's a worry. It's new problems, new issues that we need to understand. This is going to be a very real problem soon. And you hope that you sort of read your design specs and sort of we need to be very careful with our stakeholders and make sure that is seamless so that we don't affect performance too heavily.
One of the things that interests me, there's been a lot of issues with forward and backward compatibility of ETCS level 2 and deployment around Europe and elsewhere. And the kit on your trains was designed some years ago. The being installed at the south end of the East Coast is being tweaked for our uniquely British interpretation, because we hate to use install anything standard, would we? It sounds like you haven't yet found out how well you've anticipated what it is that this kit needs to be configured as in order to work with whatever has now been put into the infrastructure.
Yeah, I'd say that's a fair comment. I think because of the way it's worked, we will be you're into introduction phase again of a signalling system. So it's rather that the trains come in and we get through that, you're then introducing a new signalling system, which I guess is a new start for us. So we
Tom, you fielded a lot of questions there. You really did so well. Well done to answer the questions.
You know me, I talk quite a lot, Ian, don't I? So it's...
You did really, and there was a couple of little tricky questions there as well.